So in this module so far, we've been talking about central net force or centripetal force, and this idea that when an object is traveling in a circular path, it must be experiencing a net force towards the center of its path, which we also called a centripetal force. We also know from Newton's first law earlier this year that whenever an object experiences a net force or an unbalanced force, it must be accelerating. So I want to think through what must be going on with that acceleration. So I've picked out 2 points on my circle. If I find the change in velocity between those 2 points, that's going to give me the average acceleration at a point in the middle of the two of them. Now this circle is meant to represent an object traveling counterclockwise with a constant angular velocity. So the first thing I'm going to do at these 2 points I picked, I'm going to show the tangential velocity. So that is the linear speed, how many centimeters per second that object is traveling. And that vector is going to be tangent to the circle. So I'm going to put this one in place, and I'm going to label it with a VO for initial velocity. Then I'm going to put my second one in place, and I'm going to label it with a VF for final velocity. Now, next thing I'm going to do is do kind of a backwards vector addition diagram. So usually what we do is we have the two forces, we want to see what they add up to create. What I want to do is I want to figure out how much do I need to add to this vector to get this one. So I'm going to rearrange them tail to tail. And then I'm keeping them pointed the same direction. Now if I take a third arrow that I label delta V for change in velocity, whoops, that ends up looking like that. So if I have my initial velocity plus my change in velocity, I get the final velocity. So if I assume it takes 1 second to get from here to here, we know acceleration is change in velocity over time, and so my acceleration has to point towards the center of the circle, and it's going to be whatever that change in velocity is over the time it took to get from that point to that point. So then, thinking in terms of definitions, we're going to call that change in velocity centripetal acceleration. And we're often going to abbreviate that AC. And centripetal acceleration, just like centripetal force is a force towards the center of the circular path, centripetal acceleration is the acceleration towards the center of a circular path. And even if the object has a constant velocity, like these two vectors are the same length, so the magnitude or the amount, the number of centimeters or meters per second of that tangential velocity was constant, but because the direction changed, there was some centripetal acceleration.